Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. This is video number 14 in our video series regarding the ethical use of AI research. In today's video, we're going to see how we can perform the chi-square test using the SPSS and also by utilizing the ChatGPT together with the DeepSeek. So before then, let's have a kind of a small introduction on what a chi-square is all about. So basically, chi-square test is used to test a kind of association that exists between two categorical data. That is, if you want to see whether there is a relationship between categorical data, then the chi-square test is the best option to use. Just like when you are dealing with a continuous data, then you will now use the correlation in order to do that. So uh, when we say categorical data, actually it could be a kind of nominal or ordinal. So when we say nominal, normally it's just a kind of a classification whereby no importance is attached to it. Like for instance, when you say yes and no, when you say male and female, then when we say ordinal, it's a kind of a classification whereby some importance are attached to it. Like for instance, when you have the Likert scale, that you have the strongly disagreed, agreed, or strongly agreed. So actually, their weight is not equal. Or like for instance, if you want to rate something and you want to know the satisfaction, maybe you have the maybe the rating. Some rate uh, uh, the system as good, while others rate the system as maybe satisfactory, and others rate the system as a kind of awful. So you see, also the rating is not actually the same because if the majority of the rating goes for good, it shows that the performance is okay. While if you have the majority that goes for awful, that means there is a need for adjustment in order to improve the services. So just like the grading system, when you have A, B, C, D, they are categorical data, but they are also ordinal because the A and F are not the same. So if a person got F, it means carry over, while A, it means I kind of an excellent. So if you are doing the chi-square test, you can have one of the categorical data to be nominal and one of it to be ordinal. So no problem, you can use that. Or you can have one of the categorical data to be nominal and the other one also to be nominal. No any problem, you can do that. So and you can use the chi-square to test proportion and also to test the independence. At the same time, you can test the goodness of it together with the relationship. So your null hypothesis, you will assume that maybe no relationship between the two categorical data. Then your null hypothesis could be there is a kind of a relationship between the categorical data. Or your null hypothesis could be there is no difference in the proportion of the variable in all the categorical data, while your alternative will now be there is a difference in when it comes to the proportion. So let us just have one example. Then as we are going, we will be explaining the main thing that needs to be known. So let's say we have a nominal data that has female and what and male. Or let me just start with the male because it is said الرجال قوامون على النساء. So let me just start with the male. So then let's say we want to see whether there is a relationship between two nominal data. Like for instance, we want to see whether there is a relationship or there is a kind of an association between the gender and the brand of phone they are using. Let's say male and female and brand of phone. So let me say brand, or let me call it phone brand A. Then I can say phone brand what B. So say phone brand A. So maybe there are two different brands of phones, A and B. So we want to see whether there is a kind of a relationship between the gender and the brand of watch. So our null hypothesis could either be no relationship, or we could assume that the frequency uh, is the same. Then the alternative hypothesis could be that the frequency is not a kind of the same. So let me just randomly give it a value. Let's say, and for instance, if you want to obtain this particular data from the field, so maybe your questionnaire will have a kind of two question. One of the question will ask the participants to specify their gender, whether they are male or what or female. So that will now give you a chance to know how many male filled the questionnaires and how many female filled the questionnaire. So also the second question, you will now ask them to tick on their vote or to select the brand of the phone they are using. Some male will go for brand A, while some male will go for brand B, and also some female will go for brand A, or some female will go for brand B. So let me just randomly give it a kind of distance. So let me say 10 male selected brand A, and let me say 8 male selected brand B. When it comes to the female, let's say 13 of them selected brand A, and let me say maybe 7 of them selected brand B. So now, if you want to enter this particular data into the SPSS, so that means you need to enter the data individually, because that is one of the disadvantage of the SPSS. So let me just create the variables. One, we have the gender. Then the second variable, we have the phone brand. So under the gender, I said one will be for what? For male. Then I will now use two for what? For the female. Two. Then I can say okay. Then when we come to this, which is the brand, we say one is for brand what? Brand A. Then we say two is for brand what? Brand two. So we want to okay brand should be brand B. Brand what? B. So I will now say at. So I will now say what? So okay, so now I'm ready to enter the data. So how to enter this data actually? So you see here we have 10 male that chooses brand A. So we have to enter the 10 individually. So let's say we have set one represent what male. So we say 1, 2, 3, 4, 5. We will be pressing 1 up to the 10 places. So then the selected what? All the 10 selected brand A. So and we say brand A will be represented with a what? With a 1. So you press the 1 up to that. Then we'll now come to the male that selected brand what? Brand B, and they are 8 in number. So you come back here. So 1 in 8 places. 1, 2, 3, 4, 5, 6, 7, 8. Supposed to be 18. So this one should be 1. And this one will now be. So and the selected brand 2, brand B. So that will be represented with a 2. So you place the 2 all over until you reach that. Then we are done with the male. So we'll now go for the females. Female, the 13 of them selected brand A. So you're going to enter that. You're going to enter 2 in 13 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and what? 13. So, and the selected what? selected brand A. So we're going to enter 1 into that 13 places, which will represent brand what? Brand A. Then we still have the females that selected what? Brand B, and they are 7 in number. So you're going to enter 2 in 7 places. 1, 2, 3, 4, 5, 6, 7. So this will now be brand 2. So brand B. So you're going to enter 2 in 7 places as well. So now we have entered our data. So you see how tedious it will be if you have a data in thousands. So that is just the disadvantage of this SPSS. So you have to enter the data this thing, or you can import them. So even if you are importing, that means somebody has done the work for you. So I know now maybe reaping the benefit. Okay, let us go to the analyze. So you go to the analyze, then comes to the descriptive statistic. Then under that, we now come to the cross tab. So here our gender is on the row. So and this thing will now goes to the column. So now we'll go to our statistic. So we'll now select chi-square. So actually, if you just select the chi-square, it will just give you the chi-square value and the p-value, which will just show you that there is a relationship or there is no relationship, or there is an association between the gender and the brand of phone the genders are using, or there is no association. But if you want to get the level of the association, like in the case of the correlation, whereby we have -1 to 1, whereby the -1 represents strongly negative correlation, which is inverse, that means increase in one will result to the decrease of the other. Then we have the strong positive correlation, which is 1, which shows that increase in one will result to the increase in the other. So as the values converges towards 0, it means the strength of the correlation is reducing. So, but here, since we are using chi-square, if you want to obtain that, that means you need to check the pi and the Kramers. So the pi behaves like the correlation coefficient, whereby it started from -1 up to +1, whereby the -1 represents a strong correlation, while the negative represent a weak. The positive represent a strong positive correlation, where if you have 0, it will be neutral. But the Kramers, it has a value that ranges from 0 to 1. So the strength of the relationship increases from 0 to 1. So if you have a 1, that means you have a positive, strong correlation. And also, when you have a kind of 2 by 2, that is, you have 2 row and 2 column, so it's advisable to stick with the values given by the file. But maybe if you have like 2 rows, 3 columns, 3 rows, 5 columns, so all those that involves larger columns and rows, so it's better you stick with the Kramers E values. So you now click on the continue. So you now go to the cell. So you now have to select the expected, because actually what the chi-square does is that it will try to compare the observed and the expected to see whether the difference that exists is just by chance or is by significant. So I will now say continue. So I will now click on what? Okay. So I have my output. So the first one is just the number of the entry. I have 38, and the number of missing, I got what? 0. So the second table is just the table for the observed and the expected. The count represents observed, what we have observed from the field, while the expected is calculated from this. Actually, the way to do it is your row total to be multiplied by the column total all over the total number of the observation. So that is how to calculate this manually. So it will do that for the male and the female. So the most important table is this chi-square table, whereby it has calculated the chi-square value to be 0.354, and it has also given us the p-value to be 0.55. So you remember our null hypothesis will now say that maybe no association or no relationship. So that means there will not be a kind of a difference between the frequency of the male that uses brand A, brand B, and female that uses brand A, brand B. Then your alternative hypothesis will now be there is a relationship or there is association. So that means the gender has what effect on the type of the phone uses. So your alternative hypothesis will be there is a kind of a difference in at least one of the categories. So here you see we have a p-value of 0.552, which is greater than 0.05. So in this case, actually, we are rejecting we are going with the null hypothesis because this value is more than 0.05. So we now say no relationship or no association between the gender and the brand of the phone they are using. So if you these are the chi-square calculated value. So you can also use the chi-square calculated, but here you need to uh, uh, compare this with the chi-square obtained. So let's see whether we can get chi-square table. Okay, here is a chi-square table. Okay, let me just use this. Okay, look at it. For you to use this table, you must have the DF and your what and your confidence level or the margin of error. So let's assume we are using 95% confidence level. So it means our margin of error is 0.05. So how to calculate the DF is very simple actually, which is the degree of freedom. So here, how many rows are you having? You have two. So the formula says that your rows minus 1. So that means it will be 2 minus 1. So you will now have 1. Then you multiply it by the columns minus 1. You have how many columns? 1, 2. So 2 minus 1, it will be what? 1. When you multiply 1 by 1, you will now get 1. So that means if I'm checking the chi-square table, I will check my df1, so I will go straight to where I have 0.05. So you see the value is 3.841. So I will now compare this value with this value. So you see here is 0.354, which is less than 3.481. So then therefore, if you are using this also, since the calculator is less than the critical, we are going with the what? With the null hypothesis. That is, we fail to reject the null hypothesis. So we are rejecting the what? The alternative. So we are sticking with our null hypothesis that shows no any association. So that means this difference in frequency that we are seeing is just by chance. It's not statistically significant, despite the fact that 10 male go for brand A and 13 female isn't. So this difference is not statistically significant. It's just by chance. Okay, now let's see. You see, this process is actually very long, and when it comes to the Microsoft Excel, so you see the analysis, data analysis tool pack. There is not any option for the chi-square test, but however, you can use the manual method to calculate that. So you now calculate the observed, the expected value. Then you now calculate the chi-square value. So you sum them together, and you now go to compare. You will now compare that with what you obtained from the table. So we're not going to do that because it will consume some time. So let us just copy this and try to see whether the ChatGPT and the DeepSeek can be able to solve this. So you see here we have just copied everything as it is. So let me just say perform chi-square test and conclude. So also if I want to see the level of the association, you remember we use the pi and the Kramers. So I can now say also use pi and Kramers. That is Kramers V to what? To test the level of the association or the level of the relationship. Let me say association. So I will just paste the word the values I just copied from the Excel sheet. So let me just copy this. because I'm going to take it to ChatGPT. So I will paste the same. So let's wait and see what we will have. So ChatGPT is this thing. The DeepSeek as well is calculating. So let's wait and see which one will give us the appropriate answer. Oh, okay, look at it. The DeepSeek actually has calculated the chi-square value to be 0.349, and which is almost exactly with what we obtained here. We see 0.354. So, and this one calculated to be 0.349, approximately 0.35. So likewise, if you approximate this, it will also be 0.35. So that means it has accurately calculated that. And also it has calculated the value of the phi and the Kramers to be 0.096. So let's see this. Let's check this. So you see the values of the Kramers and the distance is 0.96 and 0.096. So what this means is that the level of the association or the relationship is positive but very weak. You remember I said when we are using 2 by 2, in this our case, we are using 2 by 2, that is 2 rows and 2 columns. So I said we should go with the what with the phi, which has a range of -1 to +1. So this minus 0.96 shows a very weak positive relationship between the brand of the phone and the gender. So if you are also going by the Kramers, you have the same value, but remember the Kramers started from 0 to what? To positive 1. So that means the DeepSeek has accurately calculated everything. And it has also concluded. It says the chi-square test indicate no significant association between the gender and the phone brand, which was exactly with our own conclusion. And let's see. So you see, the DeepSeek also get the that is the chi-square critical value to be 3.841. Remember when we check this particular table, is it? When we check the chi-square value from this table, that is 1 under 0.8, so we got 3.841. So let's see what the ChatGPT has done as well. So it means this particular DeepSeek has done everything right. So let's just check what the ChatGPT does as well. Uh, so you see the ChatGPT struggle to have what we really obtained. So the ChatGPT calculated the chi-square value to be 0.069, which is not the same thing with this, because we got the chi-square to be 0.354, but still it is within the acceptance zone. So it calculated the p-value to be 0.739, which is not the same actually. We got the value of 0.552, but if you are to use that of the ChatGPT as well, you're going to go with the null hypothesis. Then it calculated the DF right. Then the pi coefficient is calculated to be 0.043, which is not correct actually. We have a value of 0.096. So, but the conclusion is will be the same. So it says since its p-value is greater than this, we fail to reject the null hypothesis. So that means no significant association between the gender and the phone. So it also says the pi, this and this indicate a very weak association. So you see, actually, despite the fact that the ChatGPT concluded rightly, but that is it concluded the conclusion with ChatGPT rhyme with our own conclusion. but the values calculated or obtained by the ChatGPT actually differ significantly from what we had. But that of the DeepSeek actually gave us almost everything right. So you see, it also says both the pi coefficient and the Cramer's B suggest very weak association. So this is exactly what we obtain using the SPSS, and also the p-value here is the same thing as what we obtain the SPSS. So just compare the time you will take to enter all these ones into the SPSS, and maybe the time it will just take you to copy this and use this particular AI. So actually this will now save you the time, but for you to use the output, you need to have the basic knowledge, which we have just explained in the video. So assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. We'll meet in the next video.